Good morning, algebra. It's sort of dark in here today. It's early. We are starting Unit 2 today. We're getting into a little bit more what I would call traditional algebra. Getting out of the statistics unit that we were in. Statistics unit is a great sort of ease into school. But yeah, we're jumping right back into linear equations and inequalities and systems. All right. Linear equations are lines, equations that model data, and it's linear in a straight line. Inequalities mean that you can include more data than just what is on the line. And then systems of equations are like two lines that would intersect at one specific point. We can also do systems of inequalities, which would be two lines that would intersect, but we're talking about the data sort of, included in each inequality and how they overlap. All right. So I'm also using the PowerPoints that come with the curriculum this year. It's new. I've never used them before because they've never been around before. So a little bit different. All right. So our learning goal today is writing expressions to estimate the cost of a pizza party. And again, if we're in the classroom, this is a lot of fun because we can talk about, what you guys like on your pizzas, how many pizzas you think you need. So you're going to have to sort of dream with me a little bit. All right, so for our warm-up, here are some letters and what they represent. All costs are in dollars, okay? We're in the US, we use dollars. M represents the cost of a main dish. N represents the number of side dishes, like breadsticks or salad or meatballs, mozzarella sticks, whatever you would get on the side of a pizza party. S represents the cost of a side dish, and T represents the total cost of a meal. So if we do this, we can't exactly discuss with a partner. What does each equation mean in this situation? You're going to hear that a lot. In this situation. So you have to use the data of the situation when you talk about it. So M equals 750. That could mean that the main dish costs $7.50. Okay? Now M equals S plus 450. All right. So the main dish, that could mean that the main dish costs $4.50 more than side dish. That should say side. Sort of hoped that I could write over the edge. I can't. All right. NS equals 6. What is N again? The number of side dishes. And S is the cost of a side dish. So I can't use numbers of what I think, but I can say that N number of side dishes at S dollars. Like if I buy so many side dishes at a certain amount of money, it's going to equal $6. Okay, that one's the most obscure one we've had so far. Now this one is an equation with all letters, no numbers. What do you do with that? All right, we can say that the total cost of the meal is, And usually the equal sign means is the cost of the main dish plus, I'm going to use words, the cost of n side dishes at S dollars. I can already tell I'm not a huge fan of this PowerPoint. I need more room to write. All right, the number 2 says write a new equation that could be true in this situation. Okay, write a new equation. This could be anything. You could sort of, I'm going to go right here. You could start as simple as, I don't know, something as simple as that. N equals 2. The number of side dishes equals 2. You could say something as simple as like M, which is the cost of a main dish, minus S, which is the cost of a side dish, equals, I don't know, 450. If I just grab this one right here, I could just rearrange those variables and say M minus S equals 450, like if I subtracted S from both sides. Okay, M minus S equals 450. And we could go on, right? All right, so let's review a little bit. What is an equation? What does it tell us? Well, we're sort of entering into this lesson talking about equations and how you can relate to something in real life with them. Because possibly until now, when you've talked about equations in math, you've just had like X's and Y's, right? Just X's and Y's. Sorry, when my head gets over there, I feel like I'm looking someplace else. It's weird. So equations, we're starting here, they represent real data. They represent how the data behaves, how it interacts with each other. Believe it or not, we're talking about equations and how they interact with each other. Crazy, I know. Can equations contain only numbers, only letters, a mix of numbers and letters? Well, we just saw some examples where equations contain letters and numbers, multiple letters, many different numbers, right? The last question asked you to write an equation that could be true. How could this equation be true? How do you know? Well, M was the cost of the main dish, wasn't it? Yep. So M plus 5 equals T. The cost of a main dish plus 5 equals T, where T is the total cost of the meal. That could be true. What if you got a milkshake? Well, M is the cost of a main dish. So the main dish has a certain cost. You spend $5 on a milkshake or dessert or a soda, and that would be the total cost of the meal, because T was the total cost of the meal. That can be true. And we don't know for certain, but we can make some assumptions. When might the equation be false? Okay. Any equation, it can be false if it doesn't balance out, if the M plus 5 really wasn't equal to T. Maybe your debit card statement said you spent $13 at a restaurant when really you only spent $10 and there was a mistake. The total cost of the meal plus the tip equals, the main dish plus the tip equals the total cost of the meal. It can be a lot of different reasons. Let's see. Yeah, it could be false if the numbers don't add up. All right, so one equation tells us that a main dish is $7.50. Another equation tells us that it's equal to the expression S plus $4.50. So one of them said main dish was $7.50. Another one said that it's equal to the expression S plus $4.50. Could both be true. Okay, are they appropriate for expressing the cost of the main dish? Yes, they actually can both be true. The first one tells us the price in dollars, and the second one tells us the price compared to a side dish. All right, so they can both be true. They can. All right, so let's move on. Imagine your class is having a pizza party. Work with your group to plan what to order and to estimate what the party would cost. Record your group's plan and cost estimate. What would it take to convince the class to go with the group's plan? Be prepared to explain the reasoning. Okay, and we're going to write down one or more expressions that show how your group's cost estimate was calculated. All right, let me pause for a second and get that ready. I need more paper. All right, we're going to try. Definitely need more paper. All right, so how many students are in our class? I have 14 Algebra 1 students. One of them is distance learning currently. Another one is quarantining currently because this is 2020. It's when I'm recording this video. And yeah, life is really interesting right now. So we have 12 students in the room, plus a teacher. How much pizza do you think we should order? Okay, let's do 2 slices of pizza. Well, let's do 3 slices of pizza because I bet there are some students that aren't going to be very hungry and they'll eat 2. And there are some students that are going to be very hungry and they'll eat 4. So let's plan on 3 pieces of pizza each. So that would be, would we say, 13 people. 12 students, 1 teacher. So 13 people times 3 pieces of pizza apiece. That equals 39 slices of pizza. Right? Oops, I moved my head. 39 slices of pizza. All right, 1 pizza has 8 slices. Yeah, so how many pieces are needed? How many pizzas are needed? If we do 39 divided by 8, we would get, let's see, 6, 5, 4, 8 times 5 is 40. So we need 8 pizzas, or 5 pizzas. So that would be 40. We have 1 piece of pizza left over. So we need 5 pizzas. Because 8 slices a piece, that's 40 slices of pizza. Cool. Look at us doing all this math. How much do you think a large pizza is? Let's say it's $12. So cheese pizza is $12. Is that what I said? Pepperoni pizza is $14. Okay, I don't know if that's what I said the first time. That's what we're going with. $14. Let's do 2 cheese and 3 pepperoni. Okay, so we need 2 cheese plus 3 pepperoni. All this math we're doing. I think that would be our total cost of pizza. So 24 plus 3 times 14, 12, 52. I think that's right. I bet you guys will tell me if I'm wrong. $76. Okay, that's what we're spending so far. Now, what about tax? Okay, there's usually tax included. Let's say it's about 7%. I'm guessing 7% tax. Okay. 76 times 0.07 is $5.32 of tax. Add that back. $81.32. All right, that's how much I've spent so far. So let's just say the cost is about $82. Okay, so that's where we are right now. I don't think it's a very good pizza party yet. Like, we're missing some soda. We're missing some cookies. I really like breadsticks. Yeah. All right. So we've got lots of plan and lots of cost estimate with all that pink writing everywhere. What would it convince to take your class to go with your group's plan? That's all right. Write down one or more expressions that show how your group's cost estimate was calculated. Check. Like, we did that. It's sort of messy, but we have our total cost is, we could say, big parentheses, 2 times 12 plus 3 times 14, forgot the 1, times 7%. And we actually do 1.07 because that adds the total cost back in. That is $81.32. Okay, that's our total cost estimate. In your expression, are there quantities that might change on the day of the party? Okay, which ones? I'd say the number of cheese pizzas or the number of pepperoni pizzas. What if our distance learners came back? Okay, what if a student who is quarantined comes back? What if we get a new student? Wouldn't that be the best? What if I'm absent and I can eat some pizza? So yeah, I think the number of cheese pizzas and the number of pepperoni pizzas would change if we ended up ordering our pizza from a different place. Or maybe it's like, well, I know there's Taco Tuesdays, which tacos are cheap. What about like Pizza Wednesdays? We decide to have our pizza party on a Wednesday, which pizzas are on sale. So that could be the reason, but those would change. Rewrite your expressions, replacing the quantities that might change with letters. Well, I'm going to say total cost would be, let's see, we need the number of cheese pizzas. We're going to say N is cheese times 12, so 12N plus 14M. We should probably use C and P, shouldn't we? That would make way better sense. Miss Carly, what's that N stand for? I don't remember. But a C stands for cheese, and a P stands for pepperoni. And we're going to multiply that times tax. I already used T. Let's use money times, we're going to take this whole thing times 1 plus the tax. T equals the tax in decimal form. Why did I say tan? I don't know. Tax in decimals. C equals the number of cheese pizzas. P equals the number of pepperoni pizzas. And M is, why did I use M? Oh, the money. So the amount of money you spend. Got it. Good job, team. Now, it did say to be sure to specify what the letters represent, so we did that. All right, a constraint. This is a very important vocabulary word. Is something that limits what is possible or reasonable in a situation. For example, one constraint in a pizza party might be the number of slices of pizza each person would have. S. We can say that S is less than 4 to say that each person gets fewer than 4 slices. I think we said S, well, we didn't say less than 4 because we said S was equal to 3, but some people will eat 2, so S could be less than 3, and some people might eat 4, so S can be greater than 3, but we don't want it to be like 5, 6, or 7, so S could be less than 4. I think we might have to stick with S is less than 4 for our constraint too. Look at the expressions you wrote when planning the pizza party earlier. Choose an expression that uses one or more letters. For each letter, determine what values would be reasonable. For instance, could the value be a non-whole number, a number greater than 50, a negative number, exactly 2? So let's talk about our constraints, okay? Very, very important here. Okay, we used M equals, we're going to ignore the tax for right now. Cheese times 12, we use 12C, plus 14P. All right, so what are our constraints? Well, if we only have $90 total, we would have that constraint. M has to be less than or equal to $90. That's all the money we have. We could say that, well, that doesn't have to be a whole number, but C does. C is the number of cheese pizzas. It has to be a whole number because we can only buy whole pizzas. And P is the number of pepperoni pizzas. It has to be a whole number. All right, so those are 2 constraints that we would have to talk about, right? 1 second. Let me change colors here. Let's talk about a different equation. If I had the amount of money is equal to, we want the number of cheese pizzas. No, let's do where it's a cost. So we're going to buy 2 cheese pizzas and 3 pepperoni pizzas, where C is the cost of cheese and P is the cost of pepperoni. Let's change our equation. Now, C doesn't have to be a whole number. And actually, P doesn't either. C and P both do not need to be a whole number because it's the cost of the pizza, and it doesn't have to be $12 exactly. It can be, it doesn't have to be a whole number, $12.50, $15, $12.34. It could be anything. It does not need to be a whole number if we do C is the cost of the cheese and P is the cost of the pepperoni. So that's another example. Let's see. We can ask questions like, can they be negative? Can any of the numbers be negative? No. Nope. Okay, can't be negative. A number greater than 50, our total cost could be greater than 50. The negative numbers, no, exactly 2. If our variable is talking about the number of pizzas, yes. The cost of a pizza, probably not. $2 for a pizza. Even Little Caesars is more expensive than $2. All right, so let's write equations or inequalities that represent some constraints in your pizza party plan. If a quantity must be exactly a value, use the equal sign. If it must be greater than or less than a certain value, use the less than or equal to sign. We did this a little bit already, so I got ahead of myself. If our total costs, let's do, if I only have $90, it has to be less than or equal to $90. That says M is less than or equal to 90. We could say the number of, if we do number of pizzas, C plus P should be equal to 5. That's the number of cheese pizzas and the number of pepperoni pizzas, we're going back to that one, is equal to 5. Or we could say C plus P, because we're not sure how many students, should be less than or equal to 5. So the number of cheese pizzas and the number of pepperoni pizzas should be less than or equal to 5. That can be another constraint. Let's see. Yeah, I can't come up with anything else. I bet if we were together in the classroom, we could. We can probably talk about it when we get back together. In planning a pizza party, what were some ways we gathered information to estimate the cost? We talked about the number of students and teacher. We talked about the cost of a pizza, we estimated. We talked about the number of pieces y'all would eat, etc. What were some assumptions we made? Well, we assumed that some people would eat 2 pieces and some people would eat 4 pieces. So we assumed that buying 3 pieces per person was enough. We assumed the number of students we would have that day. We assumed how much pizza cost, because I didn't look it up. I could have. I'm sure I have a Domino's app on my phone or something. Suppose we had gathered information differently, for instance, by asking every student the exact pizza toppings and number of slices. Would that have been a reasonable approach? How would that have changed the cost estimate? Our class is small enough. I think that would have been reasonable. Especially toppings. It would have been nice to get some more toppings. I bet our cost would go up. Students sometimes overestimate how hungry they are. I know my kids do. I think our cost estimate would have gone up because we would have ordered more food. I think that's my assumption. Also, you guys would have said, "Hey, Miss Carly, can we have some soda?" "Hey, Miss Carly, I'd really like a plate of cookies." "Hey, Miss Carly, how about some Takis on the side?" Something like that. So yeah, I think our cost estimate would have increased. Suppose we'd made a different set of assumptions. For instance, assuming that everybody loved pepperoni and would only like 1 slice. How would that have changed our cost estimate? I think overall it would have decreased. 1 slice is less than what we estimated. Pepperoni is a little more expensive. So I think it would have decreased. In planning the party, we saw some examples of constraints. Can you think of some constraints in other situations? What might be some constraints in, say, planning a field trip or organizing a community service event? Planning a field trip, the size of the bus, how many students can fit, if your field trip's outside or inside, and if it's raining or cold, how to plan for that, how many chaperones you need, if the chaperone can drive the bus, do I need to get a driver? Community service event. Are we picking up trash? Should we wear comfortable shoes? Do we need garbage bags? Do we need reflective vests? Etc. So lots of different constraints that you need to think about in real life situations. Okay, we're almost done. So our learning targets today were, I can explain the meaning of the term constraint. Constraint is something that limits what we do, be it money, time, number of things, we have constraints. I can tell which quantities in a situation can vary and which ones cannot. I can use letters and numbers to write expressions representing the quantities of a situation. This one right here is going to be the one that we are going to work the hardest to learn and to figure out, but we'll get there. All right. This we're not going to do today. You may see it in a quiz, though, if you want to push pause and think about it. But we're not doing it today. And then I'm going to add this to your glossary in Blackbaud. What exactly is a constraint? Very important. What is a model? Okay, I didn't use this word. A mathematical or statistical representation of a problem from science, technology, engineering, work, or everyday life, used to solve problems and make decisions. I use models to make decisions every day, some more simple than others. And that's it. Excellent work today.